OK, so suppose that you are reading Hacker News. And on Monday, you see somebody post C3.js, a D3-based reusable charts library. So you're like, OK, whatever. And then on Wednesday, somebody posts Chartist, JavaScript-based reusable charts. So that's a little bit strange, right? And then on Sunday, somebody posts Dimple.js, easy and flexible D3 charting. So what? And you Google it, and you find, OK, there's a Wikipedia page comparing 30 different JavaScript charting frameworks. And then there's a blog post comparing 50 JavaScript library for charts. And the blog post is 2 years old. So what? And OK, there might be one reasonable explanation for this. Maybe all of these libraries are doing really different things. Like, surely we're not just making the same charts over and over again. But then you start looking at the websites, and a sinking feeling sets in when you realize that actually they are all doing the same thing. Seriously, what? Do we just really like reinventing the pie chart? So if we're going to get to the bottom of this, we pretty much need to look at a library called D3. Most of the charting libraries nowadays are based on D3. Most of the visualizations you see on the web are based on D3. And interestingly enough, there's only one D3. There's not like 101 different versions of D3 competing for your attention. So clearly something different is happening here. By the way, this timer's not working. Just wave when I've got like 3 minutes. So it turns out D3 has a lot of examples. We'll take a look at a few. Here's a scatter plot. Here's a line chart. Here's a bar chart. Here's an area chart. So you might say, OK, putting this all together, I guess D3 is a charting library. Which is kind of weird, though, because why would you be building charting libraries out of charting libraries? And you look some more, and you find there's some crazy like cluster layout. There's this thing of congressional influences. There's who's killing whom in Game of Thrones. And is that Obama's budget dressed up as the planet Jupiter? So something else is happening here. D3 is not just a charting library. It's doing sort of general data visualizations. But what does that really mean in practice? What is it actually? And it turns out it's a DOM manipulation library. Now, this might seem really random that your data viz library is fundamentally a DOM framework, but when you think about it, it makes sense. What's unique to data visualization is the data. And then you want to render this data in some way. So you could start with like a blank slate, and you could invent some totally new technology, or maybe use Canvas. But you already have these three guys, HTML, CSS, and SVG. And they're your pals. You know how to use them. So why reinvent the wheel? Let's just find some way to get the data and have it come hang with the rest of this crew. And that's exactly what D3 does. It lets you take some data. You're going to create a correspondence between this data and a bunch of DOM nodes. Maybe those nodes are SVG circles. And then since you have this mapping, you're just going to use functions to project properties from your data into visual attributes. So let's see it in action. We've got this, or whoops, rather, this is very low level, as you may have noticed. And as a consequence of being very low level, it makes incredible things possible. You can basically do anything you imagine. But there's a trade-off, and that trade-off is that D3 makes simple things kind of hard. And to see this principle in action, we'll take a look at the scatter plot. It's a straightforward chart. It's got a couple pieces. It's got some data. It's got an SVG. It's got some scales. Now, if you're not familiar, what a scale is it just creates a correspondence between where the data is and what pixel it should go to, or what general property. And then we're going to have some axes that visualize the scales. We're going to have some labels, some of the plot itself, a legend. All seems reasonable. So let's take a look at the code. For the data, we're just going to do some sort of basic cleanup on it. It came in as strings. We want to make it numbers. For the SVG, we do some pixel math. It's like we've got to figure out the margins, and then we've got to set up the SVG according to those margins. Scales, we're going to get the scales that D3 provides, but then we're going to have to set them up and configure them and so forth. Axes, we again get like this axis generating function from D3, and then we set up some part of the DOM, and then we call this axis generator. So a little bit obtuse. Then labels, we have to do a lot more work. Now we've got to do pixel shifts. We've got to do SVG text anchor properties. It's kind of messy. The plot is where things get really interesting. You might imagine that since the plot is both the biggest part of the chart and the part where all the actual action happens, that is correspondingly going to be a lot of code. But it actually is quite concise. And this code is really neat, so we'll just dig into it a bit. First, we're going to select a part of the SVG. We're going to put our data into it. We're going to create a circle for every piece of data. Then we're going to give each circle a class. We're going to set a radius. And for the x position, we're going to use a property of the data and the x scale to determine where it goes. And we do a similar thing with y and with fill. So what you might notice about this is a few things. First, every line of this code is purposeful and interesting. Every line corresponds to something we really wanted to do. It's no weird setup here. And second, it is really flexible. Like in this case, we made a scatter plot. But you can imagine that we could have done anything with an approach this low level. So the plot is really where D3 shines. Unfortunately, the legend is a different story. You might say, OK, this legend is very simple. It's just 3 pieces of text. It's just 3 rectangles. It's going to be very straightforward. And it's not. Really, what we have here is a mess. We're going to put in the data. We're going to create a bunch of Gs and move them around in pixel math. We're going to create a bunch of rectangles, and we have to set, again, pixel math. We're going to create some text. We've got some more hard-coded pixel constants. We've got some more SVG text specification. And finally, we're going to put in the actual text. So this really showcases both the strengths and weaknesses of D3. The strength being when we wanted to actually just make something purely based on our data, it was incredible. But when we wanted to make a legend or do any kind of layout, it's a little bit like writing a website in the pre-jQuery days using just the raw DOM API. It's not impossible, but it is a huge pain. So now that we've understood this scatter plot, we can go through the other 3 D3 examples pretty quickly and really just understand what's going on. And wait, that's not a line chart. What are these otters doing in my presentation? I swear, you just leave your keynote attended for 3 minutes, and this happens to you. But it is pretty durable that they're stacking cups, and I wish that making D3 charts were more like that. I would use the spare time to hang out with my friends. So since those 30 seconds are never coming back, let's not go through all the charts. Let's just look for salvation in the form of other charting libraries. Here's a chart that C3.js makes, and it looks pretty much exactly the same. But when we look at the code, it fits all in one slide, and it's pretty straightforward. We've got OK, we're going to create this JSON options bag, and we're going to pass it in. It'll have some properties like what are the X series names, what is the data, what type of chart do we want. It's a scatter chart. We're going to configure the axes a little bit. And we can see this is very readable. It's very straightforward. And it's not the only one that will do this. There's NVD3, and it's got a kind of a similar approach. We're going to get this scatter chart model. We're going to do some configuration on it, and we're going to get the chart. So OK, we found 2 good solutions. In both cases, we didn't have to do any weird text mucking. We just got the chart we wanted, so this is great, right? Maybe we can just go home. But we haven't really figured out this lingering mystery of why are we doing this over and over if it's so easy? Surely we would have just figured out, OK, those 2 libraries are good enough. Let's move on with our lives. So what would be really great at this point is if another library would go ahead and, in addition to making a new charting library, would explain OK, guys, we know there are hundreds of charting libraries. Here's why we felt we had to make another. And Chartist, in addition to having a really awesome logo, does just that. They say, you may think this is just another JavaScript charting library, but Chartist was made by a community that was disappointed with the abilities of other charting libraries. There was always some kind of tweak you wished for that wasn't included. And this turns out to be really a fundamental limitation of this sort of declarative make-a-whole chart from a specification approach. Because this is really great if the chart you want to make happens to look exactly like this one. But let's say we wanted to do something weird. Let's say we wanted 2 subplots and variable numbers of axes on each subplot, and one is a scatter plot and one is an area chart. You can easily imagine this coming up. We'll call it our super secret special chart. And I looked in the API here, and there's no flag for turn on super secret special chart. So we're basically screwed. And unfortunately, while Chartist has done a good job of identifying the problem, they also produced an API declarative spec, and they're also going to run into the same issues. So what we're seeing here is not that the creators of all these charting libraries are idiots. They are very smart developers, and this is not easy to do. But what is happening is every library offers a different mix of like 12 features that are really nice to have. And every consumer has a different mix of 12 features that they would really like. And for every person, no charting library is like quite there. So they see this, and they're like, oh, OK, I know what to do. I'll just make a new charting library. It will have all the right features, and then this will just solve the problem. And the result is that they've made the 102nd charting library. Basically, it's a trap. So this seems as good a point as any in the presentation for me to introduce myself. My name is Dan Mané. I work with a cool dude named Justin Lan at a company called Palantir. Here's a picture. That's me. That's Justin. And there's a flying rose, and a giant cupcake, and an inflatable dinosaur, and a hedgehog. So there's some weird things going on in this picture. But when we're not taking goofy Valentine's Day pictures, we're trying to solve a lot of different problems. Sometimes it's helping areas recover after disasters, such as the tsunami in the Philippines. Sometimes it's improving drug discovery processes. Sometimes it's just making sure that supermarkets in Japan keep their shelves stocked with Pocky. What these problems do all have in common is data. You want to be able to work with lots and lots of data. And that means at some point you're going to want to make visualizations. And in today's world, that means JavaScript charting libraries. So when Justin and I were asked to figure out a path forward for Palantir, like how should we be making these visualizations across the company, we first looked at the JavaScript charting libraries. But it was clear, first of all, that we had one feature we really wanted, which is interactive drag and zoom, that none of these libraries had. It was our, oh, we should just make a library to do this moment. But second, we have literally a whole laboratory of designers coming up with kind of zany visualization ideas. And if we go to them and say, OK, here are the 12 charts we're ever going to make for you, they will not be happy with us. And we could use pure D3, and we've done that before, and it works. But we know from experience that means that for ages to come, Palantir devs will be forced to spend their time worrying about, like, why is the axis off by 1 pixel in Internet Explorer and fine in every other browser? And then they're really not solving those problems that we would really like solved. So the question was, can we find a sweet spot, something that exposes the power and flexibility of D3, but also has some of the convenience of using a charting library? And spoiler alert, I think that we did it. It's called Plottable. It is built on D3 and tries to extend the D3 philosophy wherever possible. It's written in TypeScript, which is awesome, by the way. You should come ask me about it later if you're curious. And it's hosted on GitHub. Now, I could talk for a little while about the philosophy of the library and kind of like Socrates pontificate while you look away, fall asleep, or bang your head in disgust. But instead, we'll just jump to some examples. So here's our old friend, the D3 scatter chart. And here's our new friend, the Plottable scatter plot. And we'll just compare the two. So D3, we had to do some data munging. Plottable is just going to handle that for you. D3, we had to do a lot of SVG setup, some pixel math. Plottable is just going to handle it for you. D3, we made the scales. We needed to configure them. Plottable, just make the scales. They'll auto-configure. But you have all the same API points if you want something special. D3, we have to do a lot of work for the axes. Plottable, we just get the axes. And D3, the labels were weird. Plottable, it's simple. But when we come to the plot, this is the interesting part, right? Because we actually loved what D3 was doing here. Pretty much every line of code was good. So if Plottable is just one line here, then it means that we've fallen into the trap of providing no flexibility. And the Plottable invocation is actually almost exactly the same. All of these API points we cared about are being revealed directly. The only thing that's hidden is the fact that we're setting up circles is encapsulated within the scatter plot constructor. And then, of course, the legend, which was a huge mess of code, becomes just one line. Now, you may be asking, OK, well, I've been paying close attention, and you never set up the layout of this plottable chart. So what's the deal with that? Is it magic? Am I going to have to ask Albus Dumbledore how my chart is getting put together? No, it's just a layout engine. It's based on two concepts. One is that you can merge different pieces together, and one is that you can align them in a table. The table turns out to be a really convenient abstraction for representing charts. because it represents the constraint that different pieces need to align to each other. In this case, the axes need to stay aligned to the plot. And it's also easy to represent in code and kind of easy to visualize how your chart will turn out just by looking at the JavaScript. So we can see that we kept the strength of D3 that we really liked, namely the power over the plot, and all of these weaknesses are gone. Now you may say, OK, that's great that you can make this scatter plot, but we've already seen that other libraries can also make the exact same scatter plot. So this is not really showing off any flexibility. So we'll have another example. Suppose you have a really kind of annoying customer, not that those exist, but whatever, and they want a bar chart that is going to show the amount of rain in 3 different cities in California. So you're like, OK, that's straightforward. Plottable provides me with this clustered bar plot, and I'll just set it up, and I'm sure they'll be happy. And you go to them, and they say, no, 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 you've completely misunderstood us yet again. We didn't want a clustered bar chart. We wanted 3 bar plots vertically stacked on top of each other so that we can easily see the difference from each series. Luckily, that's just a table. So we just lay out another table, and we have this like crazy chart. And maybe they say, OK, well, that's good, but we want the SVG to be bigger. We want all the font sizes to be bigger. And most importantly, it all needs to be in Comic Sans. Now, this is going to look terrible, but you don't need to break out your abacus to do pixel math. You just change the CSS, and you get this like really ugly chart. But let's not do that. So we'll go back to our original chart. And maybe they want some grid lines. You just make some grid lines, you merge them in. It's simple. Maybe they want to add animations, so you can just set animation to true, and you get these animations. But I'll note that the animate true just sets the default animator. It exposes the full D3 API for creating custom animations and transitions. Maybe they want to change over to line plots. You can just do that. Maybe they want to use a super sweet plottable time axis. You can just do that. Maybe they want to merge it all back together into one plot. You can just do it. Change the grid lines a bit. Sure. Add interactive pan and zoom. Why not? So the net result here is we were able to create like this chart. And we weren't able to just create it, but we were able to iterate really quickly on lots of different ideas. It's probably an order of magnitude faster than working in pure D3. So if I were giving this presentation a week ago, this would be the end. But during a dry run, some friends were like, well, if you've made this library of chart components, why don't you build a simple charting library out of it? It'll be really easy to use, and then it'll provide a sort of path back into Plottable for people who get into it. So I had this long plane ride to get here to Berlin. So I was like, OK, sure, and built ChartAgrafier. It's basically Plottable in easy mode. A couple invocations follow. In every case, setting up the chart itself is just one line. And then we configure some labels and render it in the other lines. So it's super, super, super simple to use. But what's interesting about this is, A, its API is practically non-existent. It only gives you these charts. And B, it has a path to flexibility, because rather than trying to be a charting library that does it all, it just has this call called getComponents. And when you call getComponents, it will give you all of the plottable pieces. And you can swap them, or like twiddle with them, or put in new ones, or do whatever you please with it. So this enables a new workflow for developing charts. You can start with ChartAgrafier. It'll be incredibly simple, 30 seconds and you have your chart. You'll very quickly want to change it. And then you can just drop down into Plottable. And now, every 5 minutes you can be trying out a new layout. And then maybe you discover that you want some super special, fancy data visualization piece that we don't already have. Well, then you can just drop down to D3, write a plugin, and you've got your chart. And hopefully you submit it back to us, because then other people can benefit from your awesome plugin. So now comes the moment in the presentation that you all didn't know you were waiting for. Which is internet spaceships. So that was a clip from a video game called EVE Online, which is known for being a mix of spaceships and spreadsheets. And as we all know, a spreadsheet really means someone out there is crying out for some data visualization. So you can see this? Great. So we're just going to go to Plottable.js and check out this example, because it's kind of neat. So what we have here is a chart that is showing off a couple things about Plottable. One, it's showing off that my design skills are not very good to begin with, and at 5 a.m. in the morning, they're even worse. Two, we're seeing that we can handle highly dimensional data. So each circle represents a spaceship. Its color is what race. Just out of curiosity, how many people here have played Eve at some point? OK, a smattering. So every circle here is a spaceship. We can see its color is representing what faction built it. Its radius is showing what kind of ship it is, like is it a frigate, a battleship, and so forth. Its stroke is showing us what class of entity it is. And its X and Y positions are showing how much shield and how much armor it has. So this allows us to very quickly pick out trends that exist in high dimensions. So like the fact that all of these faction ships tend to have much better stats. Amar ships tend to have more armor. Caldari ships tend to have more shields. And I actually got this data source from some person who had done it by hand. And as soon as I put it into Plottable, I saw all of these typos where things just were not fitting the pattern. It also has tooltips. This is not actually a feature in Plottable yet, but because it's just D3, you can just set them up the way you would in D3 using other libraries, and it has this nifty pan and zoom. Now, the interesting thing about this chart is that in my mind, it is incomplete. I think we should have a legend that shows stroke rather than just filling in the whole bubble if people are going to do this more often. And I think that we should have another legend that's going to show different radii of thing and how a radius corresponds to data. So maybe this is where you come in. Because the whole point of Plottable is that it's very modular, that it's very pluggable, and should be easy for other people to work with. So maybe one of you guys will just head over to our GitHub and take a look at the code. And you can just write these legend pieces, and then everyone will be able to use them. Because I think that is the path forward out of this mess of 105 charting libraries. We need to stop independently building totally separate things that don't interoperate. Instead, what we need to do is we need to find one API that is sufficiently expressive to cover lots of use cases, and then work together to build all of the pieces so somebody a year from now can just trivially throw together the chart they want and get back to saving the world or hanging out at the aquarium with otters or whatever it is that they want to do. So I think this is actually the real end of my talk. Let's see if I have any more slides hiding. Nope. So my name is Dan Mané. You can find me on pretty much any service you'd want to find me as @DanMané. More importantly, you can find the website for Plottable here at Plottable.js.org, and you can fork the source. And that's all. But since I have 1 minute and 20 seconds, I'll take at least one question, if anyone wants to ask. I'll take that as a sign that my slideshow is so conclusive that you're just downloading Plottable right now, and I don't have time for questions. All right. Thank you, guys.